Sea level rise and CO2, are they linked? Everybody else is saying that they are linked. You can read the slide. Is there a cause and effect? We're going to find out. This question will be answered. How about weather? People are trying to link weather and CO2 all the time. And does CO2 influence the strength or severity of storms or the frequency? We're going to find that out too. And by the way, we're going to talk about correlations. Some correlations are positive and some are inverse. Correlation does not necessarily mean causation. Just because two things happen at the same time, it doesn't mean they're related. This is what people are saying New York City is going to look like. This happened to be the book jacket cover of a, I'm not endorsing the book, by the way. However, this will never happen in your lifetime or the lifetime of your descendants. It just isn't going to happen. We're going to find out why. This is what New York City 400 years ago when Henry Hudson first sailed up the Hudson River to discover it. Sea level hasn't changed too much. It was all forested. This is New York City today. This is landfill, by the way. These buildings are on land that didn't exist then. In fact, if you stand here at the South Street Seaport and walk uphill to Broadway, you're actually walking up to the original Manhattan Island. Water Street that runs around here is called Water Street because it was underwater. And so the landfill, they didn't build it high enough, which is one of the reasons that Hurricane Sandy did have an impact on New York City. Let's go back a little bit. And Hal talked about this too. 2,000 years of temperature versus CO2. Now CO2 has been pedaling along here for most of the 2,000 years at 280 parts per million. Not much change until right here under the blue arrow. And I'm going to talk about that subset in a minute. But you had the medieval warm period where temperatures were certainly rose, CO2 unaffected. And the little ice age when temperatures dipped and dropped. We had people skating and crossing the Thames River in England on ice in the winter. If you look at the old Dutch masters' paintings, you have people skating on canals in Holland. You don't see that anymore. It was cold. It's also, this is called the Maunder minimum. It's a period of time that sunspots disappeared from the sun for about 160 years. I'm going to talk about that later on in the presentation. And here's a subset from 1880 all the way up. You notice the first part, temperatures are still dropping even as CO2 rises. But 2/3 of it is correlated to temperature. Temperature goes up here, CO2 goes up. Up here is a little, this is that pause that everybody was talking about. But so you have a 2/3 correlation of temperature, but it's still a subset of a 2,000-year, very, very much of a flat line. The National Climate Assessment is using this to convince you that CO2 has an effect on temperature. In reality, it doesn't. I'm going to talk about weather events. Remember my first slide talking about weather? Here are hurricanes. People love hurricanes. Why? They're great heat transfer mechanisms. But how about hurricanes frequency? This is the hurricane strikes versus CO2. CO2 is in the bottom. Remember we started at 280 parts per million. Now we're up to around 400. Somebody could look at this graphic and say, we need more CO2. Why? Because there's an inverse correlation here between hurricane strikes and CO2. This is a concept called accumulated cyclone energy, ACE. You can look it up the internet. What they do is they take 6-hour slices of time over cyclones, tropical cyclones, hurricanes, and they measure wind speed, pressure, all the factors that determine the strength of these cyclones. Now, if a statistician looks at this, and NOAA does, and you say, hey, there's really no trend over the years that since they started this concept and started measuring it. The last 15 years is a decided downtrend. Of course, the last 15 years, CO2 has accelerated mostly, but there is no trend or a downward trend. Again, inverse correlation. How about tornadoes? Number of tornadoes. Now, by the way, before satellites, we could only look at tornadoes that would touch down where people could see them. But there were tornadoes in the 1800s that struck a wooded area and lifted up. Nobody knew they ever existed, but now we have radar, we have satellites. we have a better count on tornadoes. And the tornado counts in all categories at 5, 4, 3, 2, they're all heading down as CO2 goes up. So CO2 is rising here, and the counts are either down or they're flat. So tornado frequency is inversely correlated to CO2. How about temperature? Here we have tornadoes over the period, and you have some outliers here. There's some years where we had lots of tornadoes. But temperature rising, tornado count in general heading down. And that is also something that most kids are being taught the opposite. We're heating up the planet, we're going to have more tornadoes. Doesn't work that way. The data shows otherwise. And data is what counts here at NASA. You guys know that.
That's just in the U.S., right?
That's correct. These happen to be the best statistics we have, and that's why you're seeing them. This is not the U.S., this is worldwide. Anthony Watts came up with this slide. This is the total count of global precipitation. It is basically flat. Now, people have said, we're warming the planet, the air can hold more moisture. No, it doesn't happen. The air has an ability to hold moisture up to 100% humidity, and then it rains. So the atmospheric moisture in the atmosphere itself is relatively steady, and so is the precipitation. Nice picture of storms here. I probably had one outside. I could have done a better job. All right. This is one of the latest projects of the EPA. They want to regulate CO2 aircraft emissions. Now what you're seeing here is a particularly clear day over France. This is France, this is England right here. And what you're seeing here are jet contrails. These are jets that are flying in the atmosphere, they're leaving a vapor trail. And what happens is that sunlight hitting these vapor trails bounces off at wavelengths that CO2 can't intercept. It's called albedo, and if you have more of these vapor trails, you've increased that albedo. When the sunlight hits the ground and converts to infrared, at nighttime, if it hits the same contrails, it gets re-radiated, because long-wave radiation will get re-radiated downward. So you have a situation on a normal day where contrails do affect temperature. Now, after 9/11, for 4 or 5 days, we had no planes flying anywhere in the world. They just grounded all flights because they were worried about more bombs after 9/11. So the interesting thing is the temperature records from those days showed that we had higher highs and, lower high temperatures and higher low temperatures at night. We actually dampened the temperatures. Why? Because the sunlight went right down to the ground, converted to infrared, but didn't get re-radiated down. And at nighttime, there was no radiation going down either. So you had basically a dampening of the weather effects because there were no, the contrails basically dampen weather effects. And when you don't have them, nighttime radiation releases the radiation, so you had cooler nighttime temperatures and warmer daytime temperatures because the infrared heated the atmosphere. So why would EPA want to regulate a factor, contrails, that dampens climate? They're worried about climate extremes all the time. This actually helps lessen climate extremes. I won't go into what I think about that process. Atmospheric temperatures basically flatlined. We did have a new El Nino here, but we're down right again into a La Nina situation at this point. So we still have basically an atmospheric temperature flatline, even while CO2 is rising. 1/3 of man's climate influence in 1750 has occurred, and we still have a flat line. Here's sea level rise. Sea level rise is a big problem. It's the headline of my report here. We're looking at what happened when the big giant glaciers melted, the ice sheets, the Laurentide ice sheet. You had a huge, huge rise in sea level as the ice melted. About 7,000 years ago, the ice stopped melting because there was no more ice to melt. The Continental Glacier was gone. This is the most recent sea level. You notice the current projection or claim from the National Climate Assessment is that we're going to have this much sea level rise in the rest of the century. In the last 8,000 years, we couldn't get above 2 meters. Yet Jim Hansen is saying we're going to get 6 meters. It's just not going to happen. We have to invent new laws of physics to get this kind of sea level rise rate change. This is what the satellites are showing as a rate of change. It just isn't happening. There's issues with the satellite data. If you ever see my ICC 9 presentation, which is on my website, you can see where I actually go into the details of the satellite resolution of sea level. It just doesn't work. I call that presentation, Will the Real Sea Level Please Rise? Because we talk about the different ways of measuring it. This is the 7,000-year period within which sea level rose as the giant glaciers melted. These are tide gauges. I like tide gauges. Why? Because they are direct measures. This one happens to be in New Hampshire. It's anchored to the bedrock down here, loosely tied to the pier. There's a float inside that measures the sea level every day. Tide goes in, tide goes out. There's some high tide variations here, by the way. We're talking about 8 feet in a day. Here's the bias in tide gauges. Why is there a bias? People put tide gauges where the sea level is, quote, rising, or maybe where the sea level is, the land is sinking. Here it is worldwide. This is a NOAA global. The average is weighted toward the places where the tide gauges show a sea level rise or a land subsidence. If you take an average, you're going to get an exaggerated high number. Isostasy is the principle of, it shows what happens when ice builds up the giant glaciers and presses down on the land. The yellow part is called crustal deformation, and it presses down on the low viscosity asthenosphere, and that ends up creating some bulges outside. But this is huge. This is 3,000 meters of ice. It's an incredible weight on the Earth. And by the way, ice is very, very heavy. If you have a cubic meter of ice, if I could hold it in my hand, I can't, by the way, it's 1 ton. If it was water, it would be 2,240 pounds. It's very heavy. And you put these 1-ton blocks stacked up 2 and 3 and 4 miles high. That's an enormous amount of weight. And when you relieve that weight, the land bounces back. It's called glacial rebound. So this is tectonics in the Baltic. The Baltic is, this is Denmark right here. This is the Baltic Sea. Here's the center of Norway. This is Holland. And you can see that the yellow part is where you have crustal rebound, and the blue part is where you actually have crustal subsidence. The maximum here happens to be the Netherlands. That's why they have all those dikes. They need them. Central Norway, 800-meter rebound. If you ever go to central Norway, the mountains there are huge. But right here, this is like the zero line. Right here, you have a place which is basically what I call tectonically inert. If you have rebound on one side and subsidence, it's like the middle of the seesaw. And we have tide gauges in some of those tectonically inert areas. This is actually Denmark, and this shows you, this is the 1.5 millimeter, 1 millimeter, half millimeter. This is the zero line right here. But these tide gauges aren't long-term enough, but right below it is Wismar, Germany's. And Wismar has a tide gauge, which is, and I call Wismar tectonically inert. It's not quite inert. There's about a 0.4 millimeter sea level adjustment because it is slightly outside of that zero zone. But the tide gauge shows a very, very linear increase in sea level over the years. Sea level, why does it rise? Thermal expansion. A lot of reasons sea level can rise, but CO2 is apparently not one of them. Here's a CO2 chart. You see CO2 going up to 400 parts per million today. Do you see any signal in the sea level, linear sea level rise of CO2?
What's the scale, Tom, in rise, meters?
Yes, it is meters. But the point is it's linear, right? Linear is the key because you should, with the acceleration we're seeing in CO2, see some signal in that linear sea level that shows the effect of CO2. And I don't see it. If you guys do, let me know. Let's try New York City. New York City has a slightly different profile. Why? Because the sea level is rising more in New York City, or maybe New York City is sinking a little more than Wismar, Germany. New York City is packed with bedrock, and on the bedrock are skyscrapers, structural steel, concrete, water towers on top. They're very, very heavy. And so New York has been building them for the last couple of hundred years. Sea level in New York is still linear. However, the rate is different. Here it's about 2.8 millimeters a year because it is pressing, that bedrock is pressing down. I contrast this with two other places. New Rochelle is 15 miles away from New York City. The trend here is relatively flat. No skyscrapers in New York, in New Rochelle. Same with Port Jefferson. It's about 45 miles away. Same ocean. Also linear sea level rise. I put them all on one chart and you can see the difference. There's New York going up, and these are kind of flat. Shorter time frame.
But there's some cyclic pattern there on the lower two. Why do you see that?
So, yes, you're right, and they actually match. And I honestly can't tell you. I don't know.
There's a definite time. It looks like the uniform cycle.
You're right. Well, the fact, they're located very close to each other on the same ocean. This is not something you wouldn't expect. I would be concerned if you saw something on the opposite going up here. You know, but it's not.
New York City, but the scale is different.
Oh yeah, the scale is much different. This goes back in the 1800s. And the same cycles kind of show up here. The point is, you have sea level rise that is linear and unaffected by CO2. This is from the U.S. Army Corps of Engineers. National Climate Assessment has this chart in it. And they're showing that for the rest of this century, all right, we're going to see up to 6.6 feet of sea level rise, maybe 1.3. The reality is very different. National Climate Assessment, I don't think that part is worth the paper it's written on. So before Paris, I made this chart. Can the Paris proposals to reduce CO2 have any effect on sea level? So here's the National Climate Assessment chart. Wismar, Germany. If they're reducing CO2 by 1% at max, if you can't see a 38% signal in sea level rise, how are you even going to measure one?
Excuse me, Tom, but
Yes.
you're also making the point, but not saying that sea level rise is not sensitive to global mean surface temperature.
That's correct. Neither CO2 nor temperature. But
Because we know temperature's gone up kind of like CO2.
temperature's gone up, but not as much as CO2.
Yes.
All right? So neither, you know, the fact is sea level is basically working on the energy that the sun pours into the ocean and that the ocean absorbs, and the thermal expansion is what's making the sea level rise. Some internal heat from the earth too. This is what New York City really is going to look like. All right? Abundant energy, no real sea level rise.
The common claim by alarmists that melting of Antarctica,
Okay.
Antarctic is what's going to make.
It's very hard to melt Antarctica when the temperature is almost always below freezing. All right? And the
Other claim
Yeah.
about sea level rise.
And the Arctic, the floating ice in the Arctic is melting, all right? And that does have an impact, but it also has an impact on the meteorology of the Arctic. And when you melt that ice, you end up getting snow deposition on the shores of the Arctic, which change the albedo of the Earth, which make it cool. And this year, right now, as we speak, we have a record minimum ice coverage in the Arctic. It's about maybe at this point 500,000 square kilometers less than normal. It was up to 2 million for most of October and November.
You're talking about sea ice.
That's right, sea ice, floating ice, okay? And what happened is that there was enough open water to suck off the moisture, dump it on Asia. Northeastern China had the coldest October ever on record. Why? Because of the early snow. The early snow reflecting sunlight that doesn't get absorbed, doesn't heat the ground. So weather is affected by that. But we're talking about cause and effect of CO2, and CO2 just doesn't cause a rise or fall in sea level. So emphatically, I'm saying no. There is no cause and effect with CO2 and sea level. And the data supports it. All right, how about weather? Weather, we had a bunch of inverse correlations. But again, correlations and causations are something totally different. And as that's why I say in the bottom here. Okay, this is what you need to be really concerned about. Solar activity. Remember I talked about the Maunder minimum? Maunder minimum is when we had no sunspots for 150 years, which means much less energy coming to the Earth. Why? Because sunspots churn up storms on the sun, send particles to the Earth in the solar wind, prevent cosmic rays from hitting the surface. When you take them all away, the opposite happens. And now we're seeing a decrease in solar activity. Take a look here. This is the part that really, really concerns me. You notice here we have 3 or 4 months with no sunspots at all. Here's one. Between this low interval, we had 4 or 5. And now we're actually halfway down the cycle, and this has happened in June and July of this year. We had something like 14 to 18 days of no sunspots in a part of the cycle that doesn't even get down to zero. We're right here now. There is a marked decrease in solar activity, and what's worse, the interval between the low spots seems to be stretching. Instead of an 11, 22-year cycle, where the sun's magnetic field literally flips around at the end of the 22 years, we now have an 11 and a half, 23, 24-year cycle. So we're stretching the intervals, we're lowering, and this has a direct impact on Svensmark's theory on influence of cosmic rays on cloud cover. If you admit more cosmic rays to the atmosphere, according to Svensmark, you increase the particulates that water vapor can condense upon to create clouds. And if you create more clouds, you increase the albedo of the planet, or reflectivity. Again, sunlight comes in, hits those clouds, bounces off at wavelengths that CO2 can't intercept. The planet has to get colder. The same thing happens, by the way, with the pollution that the Chinese are pouring over the Pacific Ocean. Now, they're working very hard to get rid of it, but again, the particulates go over the ocean, clouds form on them, so the Pacific then becomes cloud-covered and reflective. When you fly over an ocean, it looks dark. Why? Because the dark water is absorbing all the sunlight that hits it. If you interrupt that sunlight with increased albedo, and increased albedo, by the way, can totally overpower the effects of CO2. And lately, it has been. This is what we do here. You saw a lot of data in this presentation. This is the motto that we have here. I tried to convince the World Ocean Conference to make it their motto too. What I've done then, as a result of what you've seen, is propose this for NASA, EPA, DOE, the Department of Energy, and U.S. Army Corps of Engineers. And simply it says for the past 135 years, CO2 has accelerated 38%. We have calibrated, measured, and validated sea level rise. It has not accelerated at all, right? Sea level rise just don't show acceleration. Every model showing that acceleration has failed, including the ones that ended up in the National Climate Assessment and by osmosis, if you want to call it, have been incorporated into the individual states' climate assessments. These models are not accurate. Here's one from the state of New Hampshire. And this is basically straight out of the Army Corps of Engineers. Sea level has been flat, and by the way, continues to be flat. Where this is supposedly valid, sea levels have risen in this 23-year period, right here, 0.5 millimeters, right? Almost nothing. And here they're showing feet going up. This can't happen. And yet this is part of a state publication. And they're doing public policy based on this kind of, garbage. So, as of today, there's no acceleration signal whatsoever. So I'm proposing that until such a signal begins to appear in the measured sea level, that we just don't use these models in public policy decisions. They're not valid. And then I say in the end here, EPA has to get back on mission. They have to focus on poisons, carcinogens, toxins, and processes that kill people. CO2 is not one of them. That's my presentation, folks. Now, I'll take a couple of questions, but I'd like to also let you guys know that Keisha Rogers is here. She ran for Congress here a couple of years ago, trying to rejuvenate the space program. So that's a plug for you, Keisha, okay? So, all right. Any questions?
Tom, that's on your website?
No, but I'm going to put this on the TRCS website. Jim's going to get the slides, and you guys at least know the context. Maybe the video will go on there. I don't know if that's something.
We're working towards a lot of things, but we'll start off by circulating these presentations by email.
Okay.
That's the fastest way to get them out there.
Well, you're going to get the whole slide set here.
Yeah.
And by the way, I mean, for background, I gave this at the World Oceans Conference in China. That's their logo on the top here. They did not approve this, by the way. This came later. I just am using the same logos. Where I chaired the oceanographic section of the World Oceans Conference. These slides were presented to them, and with understanding. In this country, we don't get the understanding. The politicians don't want to understand that CO2 and sea level just are not linked. And I can't emphasize it enough.
But Tom, did that conference say that? In other words, was there consensus?
No, no. I said it, and I presented at the conference. There were other people presenting, but nobody else presented on sea level rise and CO2 connection. So in that regard, I also gave a presentation on the ocean currents and the formation of the great ice ages, but that's a different presentation. Yes, Hal?
Suggestion for a project, maybe. From what I've dug into the social cost of carbon being used to justify all the regulations, a biggie in there is the worldwide damage from
Yes.
sea level.
Yes.
And I've got some contacts at the Heritage Foundation that have 2 of those integrated assessment models. And they are able to go in there, and I said, what are the equations that relate global mean surface temperature to sea level rise? And there's a few lines of code in there. You know, somebody made up some equations.
They made them up, and they are worthless.
Well, it may be useful, because we're going to be attacking the social, to go in there and look at what they've got and critique it.
I'm happy to do that, and you notice in here I say that models not relying on measured, calibrated, and validated data may, of course, continue to be used for research tools and stuff like that, but not for basing public policy upon. You want hard data, and the fact is sea levels just are, for the last 150 years, flatlining, and there is no evidence whatsoever that they're going to change that direction. And until they do, they should not base public policy on it. Real simple.
Well, EPA doesn't have that message yet.
They will.
And I think they're getting it.
I think they will. I mean, I've sent this to them. They may decide to listen.
Statement, it's flatline, there's no acceleration.
That's right. It's linear. It's linear. Yeah. It's not flat line in that it's not flat, but it is absolutely linear and no signal whatsoever.
No acceleration.
That's right. Yes, Keisha?
How do you take the basis of what you're presenting and instead of using it for refuting fraudulent climate changers, because I don't think they're going to be relevant anymore, especially the fact that we've just had a new transition into a new presidency and that's not going to be the continued policy. Take what you're presenting and move it forward toward the next phase of science investigation into the mapping of the moon.
Okay. Well, hang on. It's a very good question. There will be a new national climate assessment. It's already in the works. It has been started under the Obama administration already. They were trying to hurry it into publication before Obama left office. That new assessment is filled with charts like this, okay? They are invalid. I think President Trump is going to insist that we're going to have a new national climate assessment. It's going to have measured, validated, calibrated data in it. This cannot be in there because none of this is. This relies on models that are neither of the above. So we will have a new national, and then we need to use this as an educational tool in schools. Kids need to be taught that, hey, there isn't a relationship between CO2 and sea level rise. They're not being taught that now.
All kids should have to watch Our Mr. Sun and the Mystery of Our Cloud, because if people see that and they really have a sense of how the process works and cloud formation and looking at what Spinmark and others were doing, you can make it relevant for young children to be able to really see how this process
But
works.
getting that into the curriculum in schools that have already textbooks showing the opposite is not going to be a quick fix. We need videos like we're doing right here, and communication skills that our people have. And Hal and I and Leighton have gone to a number of conferences, and Alex has too. We're spreading the message to as many people as we can. We're going to get it right.
Hey, Tom, have you looked into how NOAA went into the ocean temperature data, the past temperature, and recalibrated them to show that there was no cause?
Okay, I actually made a comment about that at the last presentation at ICC 10. And I talked about the mixing of data. We have new sets of temperature sensors called Argo buoys, which we have placed all over the world. The old data was based on temperature readings from ship engine intakes, because ships sailing on the ocean would take ocean water in to cool their engines and then exhaust the water. And there were sensors on those intakes. And they were not good data. And yet the current Tom Carl paper that NOAA put out mixed the data. And I use the analogy that people had of taking a bowl of oatmeal and adding some arsenic into it and saying, okay, this is 40% arsenic, 60% oatmeal. It's about not even half bad, okay? When you mix bad data with good data, it's all bad. It doesn't get better. You don't want to eat that oatmeal. And yet that's the stuff we have been fed by the mass media. We do have better data coming on ocean temperatures. It will be published. If they use exclusively the Argo data, I think we'll be better off. And again, ocean temperatures are gradually increasing, but very gradually. CO2 has increased markedly, and that signal isn't found in ocean temperature either.
Tom,
Yes.
how deep do those Argos
They go,
generally make?
you know, they range from surface down to, I think, about 800 meters. 700, okay. So you have a range of the upper ocean. The lower ocean is very, very uniform in temperature. We don't need to measure something that we know hasn't changed.
The deep articles have only been used since 2005.
Right.
So you don't have a long history of deep
Whereas the
articles.
ship intake is only a few meters deep.
Well, keep in mind, they used to do it by throwing a bucket over the board and pulling up the bucket and sticking a thermometer in the bucket and saying, hey, that's the temperature. So we are getting better, you know. Any other questions?
But also those ship measurements were very narrow shipping lanes. They weren't really
That's a
spread
good
out
point, too.
across
Yeah.
the surface.
Yeah.
So
Yeah, we don't have a lot of ships crossing the southern Indian Ocean.
And was the ship loaded or was it empty?
Could be sunk, you never know about it.
That makes a lot of difference.
Yeah.
Well,